anybody started to write up their reports? No? Because I want to see the draft before you write in the final version of it.
You tell us the final dates. Then that's the second in the next physics class.
No, I didn't.
So you didn't give us the due date?
Hang on. What?
Due date?
The dates?
Yes.
I'll have to check them in the teacher's room. I have them on the other computer.
What's so busy?
That's because I am so busy. Because I have to teach you and the new students. Okay.
You can email us, you know.
I could, but I won't. Alright, we'll continue here. So write this down now. So we're starting the next section of the course, which is called materials. Materials.
Easy.
That's up to you. I say easy or difficult. I said that's up to you.
I think it's actually not so bad. I think it's kind of easy. It's, certainly parts are easy. Okay. You have this? Density. Yeah, which you might remember from the first week. Continue. Okay. So you've already seen the formula for density, but I think it's good to write it down again. Density is rho, and in semester 1 you should remember that density is how much mass per unit volume there is. So that is, density is mass divided by volume. What's the dimension? Dimension of this, yeah. It is mass per length cubed, or as a unit, kilograms per meter cubed. Remember this? So I would still like you to write this definition down again.
Definition of formula.
The whole thing in the box. Write the whole box down. Write the whole box down. I know you speak English because we've talked before, so please do this. Yes? Did you write the whole box down? Did you write the whole box down?
The whole information.
No, it's a yes or no. Did you write the whole box down like I asked you
Not
to?
exactly, I don't think.
Then the answer is no, write the whole box down. Don't complicate things. Don't complicate things. So we've briefly looked at density in semester 1, briefly. Yes, at the start. Very brief though, very brief. Just in the first lesson. We're going to look at it in a bit more detail now. So what exactly does density tell us? So what exactly does density tell us? So it's almost like how compact, how tight something is with mass. Yeah? So they give you a context. Some materials have high density. Gold, for example, has a density of 19,320 kilograms per meter cubed. Okay? So that's saying that there are 19,000 kilograms in a meter cubed of gold. Gold. It's very dense material. But of course, we don't usually have a meter cubed of gold. I know I don't have a meter cubed of gold. Yeah. So what I would like you to do as a small exercise is tell me what the density is in grams per centimeter cubed. because usually we might have a centimetre cubed of gold. So tell me the density in grams per centimetre cubed. In other words, I would like you to convert this number into grams per centimetre cubed. Try this for me. Yeah, I'll write it down here. Okay, so what I want you to do, 19,320, I want you to convert 19,320 kilograms per meter cubed. I want this as some number grams per centimeter cubed. Okay, so I want you to convert. Yeah? What did you get?
The same number add to its result.
Nope. No.
So what?
No. 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 No.
Wait.
Got an answer, KJ?
Yes, 1.9
Nope.
times
Nope.
10 to the power of...
Don't give me the 10 to the power of business. You don't need to for this. What did you get? Look how quickly you've forgotten semester 1. Get an answer, Fahad? No? Terrible. Terrible. Anybody? No?
No.
Okay. Before I forget, I want everybody to write this down in their notebook as part of their homework. So write this down. Watch the first lesson tonight. No, in your notebook.
I won't see that one tonight.
It will stay in your hand until tonight.
Yeah.
What's the first lesson?
Tonight.
The first lesson of the first
Lesson 1, week 1, semester 1.
You will what?
It's on
Check
Moodle.
it, I mean.
I will check that you watched it. Yes, I can easily check this on Moodle.
Maybe you'll forget.
I know that's possible, but I think the next time I see you, I'll look at you and go, oh yeah, and I'll check it. Yeah. Okay, so watch. 19,320 kilograms per meter cubed equals 19,320 kilo is 10 to the 3 grams per meter cubed. So that would be 19320,000 grams per meter cubed. But we don't want meter cubed. What do we want? Centimeter. So what I'll do is I'll put a centi cubed on the top and a centi cubed on the bottom. Now, who remembers how big a centi is? Yeah, it's 10 to the minus 2 cubed grams per centimeter cubed. What's wrong?
Then I didn't got it right.
What did you get?
With the extra 1 0.
With the extra 1 0? Give me a number. Don't give me a
1932200.
no. Oh,
0.19.
for goodness sake. Leave me alone for a minute. I'll type this in. 10 to the minus 2. 10 to the power of minus 2 cubed times 1932 equals 19.32 grams per centimeter cubed equals 19.32 grams per centimeter cubed. So,
Zoom out a little.
huh?
Zoom out.
Yeah.
minus 2.
centi.
The fairness is C degree.
Yeah, the C is 10 to the minus 2, so it's 10 to the minus 2 cubed. See, the cube is still there.
Then why did you remove from the bottom part?
Again, you're forgetting what you learned in week 1, lesson 1. So in physics, when we write this, we actually mean this in physics, which is the same as this,
Okay.
which I taught you on your very first day. So long ago, huh? Yeah. Okay, can I go back now? So that means when you have 1 centimeter cubed of gold, you have 19.3 grams of gold by mass. So 1 centimeter cubed is quite heavy. It's 19 grams. Quite heavy. Okay. So that was that. Let us calculate. So there was some success there. Okay, so this is something with low density. So some materials have a low density. Helium, for example, has a density of only 0.179 kilograms per meter cubed. So that means if you have a meter cubed of helium, it only has a mass of 179 grams. So, you know, a meter cubed of helium, you know, would have about this much mass. It's not heavy, it's very light. Yeah? You know helium from chemistry? You know helium from chemistry? So helium, because it's so light, it's used to fill up the balloons, as you know. So helium is a very, very low density material. Very low. So what would be a medium density? So gold is 19,000, that's large. Helium, 0.2, that's very low. So what's a material with kind of medium level of density? I think a bit more wood. Yeah, it's funny because it's true actually. Because we would say water, which is what we are mostly made of anyways. We're mostly water. So water would be a medium density. And in case you forgot what water looks like, there's a picture. The density of water is 1,000 kilograms per meter cubed, roughly. And in fact, the value of the density of water is very important, constant in science, especially biology and chemistry. So it is something that you really should know, this value. It's 1,000 kilograms per meter cubed. That is the density of water. Please write that down. You should know this constant. Sometimes I like pictures, sometimes I don't. This lesson, I feel like I want pictures in this. Yeah. Okay, you have this one?
Yeah.
Yeah. Okay. So, anyways, going back to the water, its value is very important. And not only is its value very important, it's often very important to know how your density compares to water. So, for example, gold, what was the density of gold? Do you remember roughly? 19,000
Yeah.
kilograms per meter cubed. And the density of water? 1,000. So you can see that with something like gold, it is, I said 19 or 16? Was it 19,000 or was it 16,000?
19,000.
Okay, so I should say 19 then. So we said the density of gold is 19 times more than of water. So it's 19 times denser than water. So this gives us our next idea, which we call relative density. So relative density is how dense the material is compared to water. So relative density, S, is a measure of density of an object, but compared to water. So, for example, the density, relative density, is the density of the object divided by the density of water. So, if gold is 19,000 and water is 1,000, then the relative density is 19. 19 times bigger. There are no dimensions in this, which is a nice thing. Okay, so please write this definition down. Relative density.
You mean by respect compared to?
Yeah, as a fraction. Yeah. Not showing respect. Density of the object divided by density of the water. Rho object, rho water. It is dimensionless and so it is unitless. KJ, get off the phone. KJ, how did it go yesterday? You know what I'm talking about, don't you? Never mind. All right, continue. Yes. So, does anybody know one application of relative density? One way it could be useful to know the relative density of something. No?
They check if the gold, it's pure or something.
Yeah. Not as complicated as that though. Something simple. Yeah, go on. Continue. Don't stop. Continue. Explain. Good job. So, for example, that's called buoyancy. It means floating. So, as Takin said, if S is less than 1, like with wood, and you place it in water, what happens? It floats. If S is bigger than 1, like gold, and it's placed in water, what will happen? It'll sink. So this is just one example of how it's useful to know what the relative density is. Because if you're building something, it would be nice to know often if it will float, if it becomes flooded, or if it will sink. Buoyancy is the name of the concept of something will float or not. So for example, we say that, if I put this in water, it will probably sink. So we say that this is not buoyant, will sink. My cup is buoyant. This will probably float in water. Because this material, this material, what's this material called? No, it's not really paper. It's not quite paper, it's not quite plastic, it's some other name, do you know?
Cardboard.
No, not quite paper or cardboard.
Ceramic.
Ceramic? Ceramic is like a teacup, no. Polystyrene is this white material. Polystyrene. Its density is very, very low. So it's S is, very much less than 1. It'll definitely float.
So the reason to keep things warm, the density is low.
No, not necessarily. There's some materials with high density which could keep things warm, I guess. But usually, low density we care about for if it'll float or not. And usually low density means it will keep it warm, like plastic, wood,
How do you call this?
polystyrene. No, definitely not. I can't.
It's
Yeah.
like polyester, right?
Huh?
Polyester.
What the heck is that?
Polyester.
Like plastic.
You know, I don't know this material.
It's not polyester, polymer.
Polymer.
Yeah.
Guess. Polystyrene. Have your best guess at spelling it. I'm not even going to try.
What's
Polystyrene.
Yes.
Polystyrene.
Don't think that's right, but it's close enough. Yeah? I really don't like spelling chemical names. Too many syllables.
Yeah.
Glycogen.
What?
Glycogen.
Oh,
Hemoglobin.
hemoglobin, yeah. Did you guys spell it for it?
No, I was thinking polyester. It's like they make clothes with polyester.
Oh, polyester.
Polyester.
There's an extra syllable in there. Polyester.
Polyester.
I don't know if it's related to this material. I don't know. It seems like polystyrene and polyester are quite different types of material. But maybe they have the same way of production. I don't know. Polyester, polystyrene. No, I think they might be quite different, those materials.
Because
Polyester is like perfume kind of thing.
what do you call when they,
Nice smell.
you know, it's a plastic bottle when they recycle it, they make like a,
I don't know. A long,
wire type, you know.
don't know. I don't know. I'll look it up later. Look up polyester, look up polystyrene, see if they're related. I would think not, though. Not. I might be wrong, though. I don't know. Chemistry teacher might know. Okay. So here is a table of values of density. So the first one, gold, 19,320 kilograms per meter cube, and has a relative density 19.32, 19 times denser than water. I think you should write this table down, because for some of the questions you need the values. The only one you're expected to remember for the exam is water.
How long is it?
I don't know, like about 6 or 7, 8 maybe, 8
Next
rows.
next week.
It'd be a bit tight, I think, yeah. So that's the first one. So gold is very dense. Does anybody know any other material which is very dense?
Silver,
Silver? Anything else?
planting,
Something cheaper, maybe.
Aluminum.
Cheaper. Aluminum's kind of pricey.
iron.
Iron. Lead.
Yes.
Lead.
What's that?
Lead is what they use.
Using pencil.
No.
Well, not anymore. Lead is what they use, you know, when you get an x-ray and the doctor stands behind the screen when they give you an x-ray. It's usually a lead screen.
That's not the lead.
What days
We
is
use the graphite.
No. We haven't used lead in pencils for years. Pencils are made of carbon now. Graphite.
And why do you call it lead?
Because that's what it was to begin with. People shouldn't call it lead. It's not lead. In fact, it's not safe to have it as lead because you can get poisoned by it. You know, you stick it in someone's leg. It's not good for them. All right. Next, silver, which is 10,500. Okay. Next, we'll go down to nickel. Nickel is 8,900. Nickel is high density, but it is a very, very cheap metal. It's not expensive, nickel. It's much cheaper than silver.
They don't use nickel in jewelry.
Oh, they do. But they mix it with silver. So it's a way to reduce the cost. So you can have nickel silver plates instead of silver.
The same color.
Oh yeah, you see, this is the thing. This is why it's mixed with silver, because it keeps the silver looking like a white color, a bright color, you know. Salt water. Now, I said water was 1,000, which is true. But if you had something like ocean water, salt water is a little denser than regular water.
30.
That's it. It's significant. 1,030 kilograms per meter cube. What's wrong? There's absolutely nothing funny about this table. Alright, next. So, fresh water is 1,000, as you know. Now, ice. So what would happen if you put ice in water? The relative density is less than 1, so what would happen? It'll float. As you know, ice does float.
Life becomes less.
We'll see that in a different lesson. Okay, you got that one so far? Right. Next, no, there's still more. Alcohol is actually quite a lot less than water, even though it looks and seems like water. It's clear, it's a liquid, but it's not even 800 kilograms per meter cubed. It's less than 0.8 relative density. Okay, next is wood. So wood is 700.7. So of course, wood definitely floats. Wooden boats, wooden ships definitely float. And the last one is something, yeah?
If any liquid has more density than water, is there
Good, yeah. Liquids, mercury. Mercury is a metal, but at room temperature it's a liquid.
So if you put in
So if you put mercury, poured it into water, it should sink to the bottom of the water.
Oil.
Oil is less than water, so it'll float on the water. Other liquids? Well, look, salt water. If you mix salt water with water, the salt water will want to move down. It has more density.
if you put oil in it won't. It will
If you put oil in water, oil will float because it has less density than water.
it won't go down.
No, it won't. So you can try it. If you pour some, like, you have sunflower oil or cooking oil, olive oil. You pour some olive oil in a glass of water, it won't really go down. It will try to go to the top. So you'll have to mix it a lot. But if you leave it maybe overnight and go in the morning, you'll see that it should have floated back to the top. You can try it. Just put a bit of olive oil in a glass of water, see what happens. Take a picture for me as well. Alright, the last one is air, which is very, very, very low. It is only 1 kilogram per meter cubed. It's tiny. It's 1,000 times smaller than water. Okay, you got all these values, yes? Yep, okay. So let's have a look at some examples here. So this first one here, I mix 1 litre of fresh water with 1 litre of salt water.
Okay.
So the first thing is convert litre into SI units, because litre is not a proper unit. So our first question here, 1 litre. Now, remember, how many litres are in a meter cube? Does anybody remember? Yeah, there's 1,000 litres in 1 meter cubed. Isn't it? It is, yeah. So that means 1 litre equals 0.001 meter cubed. That's okay, isn't it? Just divide by 1,000. Yep. Okay, so what is the mass of a freshwater and of salt water? Okay, so the first one, the freshwater, what is the density of the freshwater? 1,000. What's the formula for density? Mass over volume equals 1,000. So what does the mass equal? 1,000 V. But what's the volume here? Well, the volume is 0.001. So the answer is the mass will be 1 kilogram. In C, the density of salt water is 1,030. Mass over volume equals 1,030. Mass equals 1,030 times the volume. So the mass equals 1,030 times the volume. So that means here you get mass is equal to 1.03 kilograms. So that is the mass for the litre of salt water. That is the mass for the litre of fresh water. And that is the volume of a litre of water. So that's the first part. Yeah. Next part, what is the combined mass, combined volume, and combined density? So what you do now is you mix the two together into one large bottle. So what is the total mass? Well, if you add 1 kilogram of water to 1.0 kilograms of salt water, the total mass is 2.03 kilograms of water. Next is what is the total volume. Now, usually, so I'll just wait a second. So, usually when you mix things together, the total volume stays the same. So if you have a litre of water, a litre of coffee, and you mix it together, you'll have 2 liquids of watery coffee. Now I say usually, but of course there's exceptions. So, you know, if you mix some kind of liquid which is an acid and some kind of liquid which is a base, then what happens when you mix a liquid and a base? What will happen? What happens when you mix a liquid, an acid and a base? No, just what happens when you mix an acid and a base? Have you done this in chemistry? Yeah, but don't you get lots of heat and fume? Lots of stuff's happening here. Yeah, like, I mean, some of the mass might have evaporated, you know? Or, yeah, what else happens? I don't know what else. I suppose if you mix boiling water and ice, then some of the ice will melt, maybe turn into steam. I don't know. I'm just saying that usually when you mix things together, the volume stays the same, but of course there are some exceptions. Huh? What are you saying?
If you have a hot water,
Yeah.
then you have something cold.
Yeah.
Mix
There could be some steam or something like this.
It's
So,
temperature.
Usually if they are neutral materials, you know, they're not an acid or a base or chemically violent, and they're all, you know, the same temperature and they're room temperature. Usually when you mix things together, the volume stays the same. That's my point. So here, the total volume would be 0.001 plus 0.001. So that is 0.002 meters cubed is the total volume. So the last part here is what is the density of this new water drink, I suppose. So the density of the mixture is the mass of the mixture divided by the volume of the mixture, which will be 2.03 divided by 0.002, which equals 1015 kilograms per meter cubed. So, when you mix them together, the density is more than that of fresh water, but less than that of salt water. Okay, you got this, KJ?
Yeah.
Yep. Okay, next. Right, here's one for you to try. You don't have to write down all the information here, but you can draw the picture. So what happens is, I can use my cup here as an example. So the student has some water in a cup. KJ, what are you doing? Okay. The student has some water in a cup, and they place 10 grams of ice into the bottle of water, and then they put a lid on the top. But please note, the water is nearly to the top, and when they put the ice in and they close the lid, it's completely full to the top. Okay, so there's no space inside the bottle. Do you understand? So the ice is in the water, the lid is on, there's zero space, extra space. Got that? Yeah. Now, the bottle of water and ice is left out on the table and the ice starts to melt. So, when it has fully melted, what has happened to the bottle of water? So your three choices are, the volume of the water in the bottle has increased. Since it is closed tight, the bottle breaks. So the water has increased in volume and the bottle breaks because it's no space. Choice B, the volume of the water in the bottle has remained unchanged. So even though the ice has melted, it's still the same amount of water. So there's still no space. Everything's the same. And C, the volume of the water in the bottle has decreased. There is now a little space. So the last choice is the water has decreased and now there's a little bit of space. So which do you think is the right answer? A, B, or C? A, B, C?
B.
So we're going for A's and B's. Who thinks A? Let's have a vote. 2 for A. Who thinks B? 1 for B. 2 for B. Who thinks C? Carrara, you're undecided. Okay, so we have 3 for A, 2 for B. Yeah? Okay, so we can calculate this and see what happens. Okay, so this is the picture that we have. So we have some ice in the water, and it's full to the top, so there's no space. So I don't know what the mass of the water is, but it's not important. And I know what the mass of the ice is. So I'll just call the mass of the water, the liquid water, ml. I know what the density of the liquid water is. What is it? 1000. And the volume of the liquid water, I don't know, but it's not important. I call it VL. The ice. I know the mass of the ice. What is it? 0.010. Yes? I know the density of the ice. What is it?
0.916.
No, not the relative density. It'd be 916, would it?
Yeah.
Okay. And what's the volume of the ice? Well, my first piece of business is I'll work out the volume of the ice. So density of the ice equals the mass of the ice over the volume of the ice. So the volume of the ice equals the mass of the ice over the density of the ice. So what's the mass? 0.010 divided by 916. So it'll be quite small. It'll be 1.0917 times 10 to the minus 5 meters cubed. Okay? Right. Now, the second, so at the beginning, at the start, what's the total volume? It's the volume of the liquid of the water plus
This
the
one.
volume of the ice, which is 1.0917 times 10 to the minus 5. Now, let's see what happens when the ice has melted. Can I go down? Okay. Yes? Alright. So, in this picture here, the ice has melted, so it's now in the form of water that has been mixed in. Okay, so again, the mass of the liquid, the original liquid, is the same, the volume of the original liquid is the same, and the density of the original liquid is the same. Now, I'll write a new symbol here, M, and I'll write Mi. What do you think I mean by Mi? Melted ice. This is the melted ice. The volume of the melted ice and the density of the melted ice. What's the density of melted ice?
1,000.
1000, because melted ice is water, so that's 1000. The mass is still the same. 10 grams of ice is still 10 grams when it melts into water. So 0.010. So let's calculate the volume. We know that density is mass over volume. So volume is mass over density. So volume will be 0.010 divided by 1000. So when you type that in, you get 1 times 10 to the minus 6. Or if you want, I'll put that as 10 times, 10 times 10 to the minus 5.
Yeah, minus 5.
With a 10.
No, now it's minus 4.
Oh, sorry. It should have been 1 times 10 to the minus
5.
5 to begin with.
Yeah.
Are you 100% sure?
Yes.
You are correct. Congratulations. 1 times 10 to the minus 5. Okay, so what's the volume now? So the volume will be the volume of the liquid to begin with, true, plus the volume of the melted ice, which is 1 times 10 to the minus 5. Now, look at the volume at the start, look at the volume at the end. Has it increased or decreased? So if the total volume has decreased, the correct answer is
C.
yeah, which nobody got right. So when the ice has melted, it becomes liquid, but because the density of ice is less than of water, it means when it becomes liquid, it has less volume. So when the ice, in other words, when the ice melts in the water to make water, the volume of the water made is less than the volume of the ice. So the result is it'll actually, total volume will decrease. Now some of you look like you're accepting this, some of you are looking like, no, this doesn't make sense. So if you like, you can put some ice into some water and fill the glass to the very top, and then put like a, like a coaster, like something like this, okay? Put in some ice. Listen. Put in some ice. Fill it up with water, and keep filling it up with water until it's right at the top. And then you can just put a lid over it, and make sure there's, something like this, and make sure there's no space. Then, after the ice is melted and you take the lid off, it shouldn't be up to the top anymore, it should be a little bit less. It definitely won't be more. If it was more, what would happen? The water would start to come out the side when the ice melts, which is not what happens. Yeah? Okay. Questions now? One more question and then we're finished. So this one is, you mix 10 grams of nickel with 1 gram of silver. So this is common when you're making jewellery. What is the density of the mixture? Do you know what? Okay, so the density of the mixture would be the mass of the mixture divided by the volume of the mixture. So if you had 10 grams of silver with, what did I say, 10 grams of, 10 and 1, yeah. So if you had 10 grams of silver, nickel with 1 gram of silver, what's the total mass? 0.011 grams, divided by the volume of the nickel plus the volume of the silver. Now remember, density is mass over volume, so what's volume? Mass over density. So this is 0.011, the mass of the nickel divided by the density of the nickel, plus the mass of the silver divided by the density of the silver. Now don't talk up. I need you to tell me what the density of the nickel is, and I need you to tell me what the density of the silver is. So what's the density of nickel? What was it? Tell me.
8,900.
Okay, and of silver?
10,500.
Thank you. So let's get the total, the density of the mixture. So 0.011 divided by 0.010 over 8900 plus 0.001 divided by 10,500. So it should be somewhere between 9,000 and 10,000. Yep, I get 9025 kilograms, point per meter cubed. So this would be the density of a mixture of 10 grams of nickel with 1 gram of silver. So if I have, this is common when it comes to jewellery. So if you have 1 gram of silver mixed with 10 grams of nickel, you have 11 grams in total, but only 1 gram if it's actually valuable material. This would be the density of the mixture. So as part of the homework, you'll have to work backwards. I give you the mixture and you have to find out how much, silver was in it originally. Okay. Right, these are the questions. I want you to try these, do these for the next class.